Good afternoon. Now, if you've been to one of my other sessions this week, you know how this is supposed to go. This makes it fun for me too. Good afternoon. Thank you so much. My name is Jason Buffington. I'm the Senior Product Manager in the Management Security team responsible for Data Protection Manager, as well as System Center Essentials and System Center Operations Manager. This is actually what I'm thinking of as part 3 of 3. In your handout, it probably says part 2 of 2, and if you only came to one other session, that means you missed the session in the office track. So, in the first session of the week on Monday, we built a DPM server, we threw out some agents, we configured some disk and some tape, and we talked about why did Microsoft actually build a backup solution. In yesterday's session in the office track, we talked a lot more specifically around how does DPM use the volume shadow copy services, or VSS functionality, in order to protect your data. And I used examples like a SharePoint farm and SQL Server databases for that. By the way, quick show of hands. If you came, did you come to the office session? Okay, maybe about 30%. For those of you that did, I forgot to mention that if you download the slides, it was an office track session, so I wanted to stick with SharePoint and SQL. If you download the slides, I included Exchange information in the back of the session as well. All right. This is the third of 3 parts. So we're going to talk about disaster recovery, meaning protecting the data to another server, which is off-premise, and then also about protecting virtualized spaces, specifically virtual machines running on top of Hyper-V. And as always, I think I've got 1 or 2 copies left of my book, and be happy to hand those out based on who has the coolest questions. All right. So what are we going to cover? We're going to start off with a very quick overview of DPM, and to decide how quick, show of hands, who in here already has seen one of the DPM sessions or has direct hands-on experience with DPM 2010? Good. Okay. So we're going to go a really fast overview to catch like the 3 people. You're one of them, just to kind of keep everyone up to speed. All right. And then from there, we're going to go into the fun parts of the session. So just to remind everybody, and by the way, if you've seen this diagram before, imagine how many times I have. Okay? I do this on cocktail napkins and pizza boxes and occasionally a conference room whiteboard. All right, all the workloads that you see on the left, Exchange, SQL, SharePoint. What we're going to be talking about today, Windows virtualization, Windows file services, Windows desktops. In all cases, we take an agent, we put the same agent binaries on all the boxes, and then based on what the agent sees determines how the data gets protected. But basically, at a byte or block level, we take that data from the production servers over to the DPM box. Now we hold that data in a live copy. And when we talk about virtualization today, we're going to be talking about the VMs themselves. And so somewhere hidden deep inside that DPM server, there really are VHDs that represent that virtual machine. So we're not just dropping those bytes and blocks into a big pile of goo. We hold the data in a native state. That's also going to be important because along with holding the data on disk for fast recovery and holding it on tape for long-term retention, the other thing we're going to talk about today is actually taking that data from one server, one DPM server specifically, which is on-premise, and taking it to another DPM server, which is off-premise, to give you a disaster recovery capability. Okay? So that in a nutshell is what DPM 2010 is all about. Heads nodding okay? We're good on this? Okay? All right. So that's my fast overview. And if it was any faster, I'd need espresso. Now let's talk about virtualization. Let's talk about actually backing up virtual machines using DPM. In the earlier examples, if you came to one of the earlier sessions, I showed you how whenever DPM protects the data, it always presents the data to you in the context that you're used to managing it. So when you want to back up Exchange, you see storage groups or databases. When you want to back up SQL, you see instances and then databases underneath them. When you want to protect virtual machines, what you'll do is you'll point the agent at any one of your Hyper-V or Virtual Server 2005 R2 with Service Pack hosts. Okay? And then what you'll get is you'll see the list of the virtual machines, and you'll just pick which virtual machines you want to back up. Now that's the behavior of what do I want to back up, but how the machines get backed up will vary based on what's running inside each guest. Okay? And specifically, we're going to put all the VMs into 2 categories. We're going to put them in the what guest OSs are VSS capable and what OSs are not VSS capable. So VSS capable guest OSs include Windows Server 2003, 2003 R2, 2008, as well as Windows XP, Windows Vista, and Windows 7. OSs which are not VSS capable are those that aren't running Windows. That's a good example. And as well as things like NT4. Anyone got a large NT4 farm still? Okay, just checking. All right. So basically that's the two categories. So let's talk about the worst case scenario. Let's talk about when the VM is not running a VSS capable guest. Here's how it works. If it's not running a VSS capable guest, then DPM has the same challenges that most other virtualization backup software has. The biggest one of those challenges is that if you can't see inside the guest, then you really don't want to just back it up from the outside, because the problem is that you don't know what's going on inside. You don't know what's in memory. You don't know what's in CPU state. And so most importantly, you don't know whether or not the application actually is in a consistent format such that you could go ahead and back up to the disk. So there's usually two ways to handle this. The first way to handle a VM, if you can't back it up from the outside safely, shut it down. Right? If you power down the VM, then it's just a big old flat file called a VHD file, and you can back it up all day long, and that's great. That technically is an option. Causes some downtime, right? But it is a viable option. So Plan B is to go ahead and attach a SAN to the bottom of your hypervisor, snap a copy of the LUN of that SAN, then flip a BCV of that snap over to another Windows head, mount it off of that second Windows head, buy a third-party Windows backup product, and then back it up from there. Right? And I'm not going to ask for a show of hands on who actually has to do that today. Okay? So that's Plan B. For the record, DPM 2010 does not require SAN, does not require a second Windows head, does not require third-party Windows backup software to get the job done. In fact, you can even run, in my demo today I will, you can even run DPM on the Hyper-V host itself and back up the entire thing as an isolated platform. Okay, so that's Plan B. We don't do that either. Plan C is basically what DPM does. We do have the same challenges everyone else has in that you don't want to back up a VM if you can't see inside it. So we go ahead and save state the machine. Once we've save stated it, then we snap it with volume shadow copy services and we bring it right back up again. So it's not down for the length of time of the backup. It's only down long enough for the disks to be quiesced. And then it comes right back up. So you should plan for something in the neighborhood of 20 to 45 seconds, depending on how long it takes you to actually save state a VM, and then right as quickly as your mouse will let you, hit resume and bring it back online again. Okay, because that's what the experience is in DPM. It goes down, takes a snap, comes right back up again. But once we have that snap, then we can do with it whatever we want. Now, if you came to the office session yesterday and you saw what we do around block level remirroring, which is what we call an express full, that's how that works. Once we have that snap, we just take the blocks, we configure out our change, and we ship those across the wire. If you didn't come to the session yesterday, if you do a Bing search, I'm told other search engines work well also, but if you do a Bing search and do a search on how does DPM really work, you should also be able to get to it from jasonbuffington.com, which is my blog. But one way or the other, you're looking for a podcast. It takes about 20 minutes, and I actually take you through literally how does the VSS writer work, how do we capture the changes, how do we replicate those across. That podcast is also really handy if you have trouble sleeping, because you can put it on repeat. And anyway, getting through osmosis. All right, so that's how DPM does it when it's not a VSS-based guest. Brings it down, snaps it, brings it back up, and then ships the blocks that have changed. Now let's talk about what happens when it is a VSS-capable guest, and specifically that means Windows Server 2003 or XP or later. This is the fun part. Without an agent inside the guest, DPM reaches out to the Hyper-V host and says, I want to back up this VM. Hyper-V notifies us that VM happens to be VSS-capable. And so what that means is when that backup actually starts, the first thing that happens auto-magically is that any VSS-based workloads inside that VM become VSS consistent. So the SQL Server VSS writer does its thing. The Exchange Server VSS writer does its thing. SharePoint, etc. The application becomes data consistent. Then the file system kicks in, and the file system's VSS writer kicks in and makes sure that the file structure is consistent or crash consistent. Once the inside of that VM is clean, then Hyper-V snaps it for us and then hands us a quiesced copy of that VM. Here's the punchline. No downtime, no agent on the inside of the guests. Okay. So to explain how this works a little bit, I want to kind of take you through a little bit more on how VSS works. Show of hands, who in here feels pretty good about how VSS works? Okay, good. Maybe 20% or so? Okay, so hang with me. The other 80%, this is cool stuff. You're going to want to look up here. All right. So volume shadow copy services. Been around since Windows Server 2003. And basically, VSS is plumbing. It's just how to get stuff from point A to point B. And specifically, VSS has three components. It has a requester, and the requester is what's done by the backup technology. And it says, I want to back you up. There's the VSS writer. The VSS writer is written by the individual workloads. And their function is, this is how I'd like to get backed up. And then there's the VSS provider, which is the storage layer, which actually says, I'll hold the stuff while you're doing your thing. Right? That's it. Other than that, VSS is plumbing. So let's kind of take you through it. So we're taking Hyper-V out of the equation for just a second. I'll put it right back in. So backup server, in this case DPM 2010, says I want to back up a Hyper-V host. This is all stuff running on that Hyper-V host machine, or any given Windows server, I should say. DPM agent, using its VSS requester, talks to VSS and says, I'd like to back you up. VSS tells the VSS writer, hey, you need to get ready to get backed up. Do what you do. And that's that's a technical term, do what you do, which translates as either trunk your logs, cache out your pages, whatever it is that you need to do to get your data into a consistent state. So the application, the workload, does that, and it comes back and says, okay, I'm ready, here's your data. Hands it back off to VSS. VSS stores a temporary copy out in the VSS provider. The VSS provider then tells the VSS requester, here's your data. And the data automatically makes its way back to the backup server. That's how VSS works. Now, let's put Hyper-V back in the equation again. Turns out it's the same equation twice. Here's what happens. Outside, DPM talks to Hyper-V on the host and says, I want to back you up. VSS talks to the Hyper-V integration, to the Hyper-V VSS writer, and here's the fun part. If you're taking notes, this is the part you really want to track on to. In one of the tiny little components inside the Hyper-V integration components, which is already running inside the VM, is a VSS requester. We didn't put it there. It's part of the integration components. So we don't have to put an agent in there. Turns out everything we need is already part of the package. So remember what I said. VSS writer comes in and says, do what you do. Here's what happens. On the inside, the whole process happens recursively. So the VSS requester inside of the integration components tells the guest OS VSS, I want to back you up. The application does what the application does, gets data consistent. Tells VSS inside the VM, yes, I'm ready to have my data backed up. Goes down to the provider, captures the data. The whole process happens recursively inside the VM automagically. Once that's done, then it does a snap on the inside, and the rest of the process happens like we normally have to. So once that's done, the VM says, okay, I'm ready to be backed up. My inside is clean. Now VSS on the outside does an external snap, hands the data back to the DPM agent, and off the data goes. That's how we back up a VM. There's a couple little messy details, though, we have to fix. Primary one is take a look at what happened. At 3 hours, 2 minutes, and 21 seconds, the inside of that VM did a snapshot. Data was clean, nice and consistent, ready to be backed up. It took, what do we got, 24 seconds from when that happened to when VSS on the outside of the Hyper-V host snapped the volume as a VHD. Unfortunately, what DPM gets is that outer shell. It's the VHD, which basically means that I've got extra stuff. I've got junk that I've got to clean up that's out of there. So easiest way I can explain this, and this isn't the most technical description, but just kind of go with it, and hopefully it'll make sense for you. Let's say I'm going to give my buddy Paul a present. Okay, so I buy this really cool present. I put it in really frilly wrapping paper, because Paul likes really frilly wrapping paper. And then I go ahead and want to ship that to Paul. Okay? What I do is I take this little box in the frilly wrapping paper and I put it inside a really, really big cardboard box full of styrofoam peanuts. Okay? And then I ship it to Paul. Sorry to pick on you, man. You're in the front row. It just kind of comes with the deal. All right. So here's the problem. When Paul gets this package, and by the way, that kind of looks exactly like this VM does. I've got this pristine set of data that the Hyper-V that the application gave me, and then I've got all this junk. I've got all these peanuts before I get this really ugly cardboard box on the outside. If you just stored it like that, so Paul takes this big cardboard box, puts it on a shelf, and someday he decides he's going to go ahead and open that up, meaning I want to restore my data. What's going to happen is when he pulls out that big cardboard box, he's got to drill through the peanuts to get to what he really wants, which is the present. Okay, so that's the end of my colorful analogy. So here's what we have to do. Basically, the last part of this process is we take that, the frilly box, and we pick it up, and we throw away the cardboard, we throw away all the peanuts, and we shrink the cardboard box. So it's a perfect fit. So it's just a box inside of a box. Once we've done that, we close the cardboard box back up, and that's what we give to our buddy. That's what happens inside of the Hyper-V VSS writer is that DPM, along with Hyper-V, we actually temporarily mount that external VM, strip out all that junk, so now that cardboard box is nice and tight, and then we close it back up again. And that's what actually gets stored, because what you actually get stored on the DPM server is a VHD, and inside that VHD, you need to have a pristine file system where the application data is actually crash consistent. Okay? Does that make sense? Everybody okay? Heads nodding like this? Okay, good. Okay. By the way, some of you in the back, I did see that you didn't nod. I'm not going to hold that against you. All right.
Is that a similar process to like what the backup exec Hyper-V agent would do?
No. Okay. All right. You know, funny thing, I called, I have some friends down at Symantec, and I asked them, hey, would you mind telling me, let me see your source code so I could see exactly how you handle it inside? And they started signing off all these regulations and lawyers, and anyway, so they wouldn't tell me how their process works. I will say this, the actual cleanup process is something outside of the, how you interact with the VSS writer itself. So that's something which is handled per application. And as I said, they don't give me their source code, so I can't confirm that. All right. So let's talk about what actually happens when you back up. So we've talked about how you capture the VMs, and what that really means is you're capturing the VHDs. It also means that you're capturing the metadata, which defines that virtual machine. So what I'm going to get is I'm going to get C drive as a VHD called fs1c.vhd. I'll get fs1d.vhd, and then behind that I'll get the metadata, which is actually the definition of that VM. The reason that's important is because one of the new features that's available in DPM 2010 is the ability to actually recover a VM to a different host than where it came from. So to do that, we had to make sure we captured that metadata along with it. So basically, on that new host, it's going to feel like you did an import. You know, because you bound the VMs, and because we have all the metadata, it's a complete experience to bring that over. So you don't have to do anything manual to bring that stuff across. There's a couple other things that you want to be aware of in DPM 2010. One of them, and this is actually one of my favorite features, is a function called ILR. ILR stands for Item Level Recovery. Now, hang with me for a second. Here's what we do. In DPM 2007, the last generation, in DPM 2007, you had to make a choice between whether or not you backed up at a host level or a guest level. And the primary reason why you would make that choice is based on what level of granularity you wanted to recover. See, in DPM 2007, you could back up a whole VM, and the cool part was you could restore the whole VM, and that was really neat. But the downside was you had to recover the whole VM. Right? So if you want to have granular recovery, you had to have first done granular backup. Okay. So in DPM 2010, you don't have to make that choice. Here's what happens. I've got my DPM storage pool over here, and I've decided I want to recover a file that happened to be on fs1-d.vhd, just the VHD from one of those virtual machines. And I'll show you this in just a few seconds. What happens is that we actually, and if you were looking for really magic source code, pixie fairy dust explanation, this is it. Here's the secret to how we do ILR. You know that VHD that we backed up from the virtual machine, and we've got a copy of it in the storage pool on the DPM server? We mount it. That's it. It's a VHD, right? As of Windows Server 2008, that's a mountable file system. We mount it. Once we mount it, we can see the file system like any other file system on the DPM server, and so we just go in the directory structure, we find the file that we need. We take that one file we want, we pluck it out, we drop it and restore it over onto the virtual server or the network share, wherever it needs to go to restore to, and then we just unmount the VHD. That's it. It really is just that simple. It does work with dynamic disks as well. There's one caveat, though, that you need to be aware of, and that is that normally, in almost every other scenario, you can have your DPM server be a virtualized DPM server. And a lot of folks like to do that. They like to just have a VM and have your DPM inside of a VM, and it works really well. There's only two caveats to having a virtualized DPM server. One of them is lack of tape drive support, because we don't have a SCSI connection that way. Now, I use an iSCSI initiator in my DPM VM, and I just use an iSCSI-based tape drive. But if you're not using that, you may have some challenges with actually using tape. The second caveat with using a virtualized DPM server is this function isn't supported inside of a virtual VM. And the reason is that even though Windows Server 2008 R2 can support mounting a VM from within, running a VHD inside of a VM, Windows Server 2008 does not. And so to design to the lowest common denominator, DPM made a choice that since we can't mount the VHD inside of a VM on a Windows Server 08 base, we can't do it inside of a VM. So hopefully that gets updated when we go to Service Pack 1. But in the meantime, that's the one caveat with this scenario is you do need to have a physical DPM server for this particular recovery point. All right. A couple other things as far as virtualization backup goes. Yes, DPM 2010 supports live migration scenarios for Hyper-V R2. Basically, here's how this works. I've got a cluster of, in this case, 3 hosts, and I've got a bunch of virtual machines that are bouncing around between them like a ping pong ball. First time I define protection, I'll know that it's part of a CSV cluster when I actually define it for protection, and so I'll back it up off of one particular node. Then in between one expressful recovery point and the next, that VM is going to move from one host to another. The next time that we go and back that up, when we go back out to CSV, we'll find out that it's no longer living on that host. We can actually browse the list and find out which host is now on, and then we'll back it up from there instead. It's completely lights out. You don't have to acknowledge anything. We basically will follow the bouncing ball on whichever host it happens to be on. One thing that you do want to be aware of is that there is a very small period of time. This question almost always comes up, so I just want to get in front of it. There's a very small period of time, usually measured in seconds, where it's in the window of when the machine is actually doing the live migration, where a backup will need to be restarted. So what will happen is that, when you do a live migration, how as part of it moves all the memory pages over, and there's a certain period of time where things are kind of in flux. Well, there's a very short period of that live migration window where it needs to have exclusive access to the disk, and the disk attributes are actually being moved from one owner to the other. During that window, you don't want the backup to be happening. So if we try to back up a machine while live migration is actually occurring, as long as it's past that finite window, then we can go ahead and pick up from there. All right. If not, if we're actually in that window, our live migration starts during the backup, then we'll actually cancel the backup and we'll actually start an automatic retry, and we'll retry it a few seconds later when the live migration window would have passed over. All right. So one of the things that, having been in backup a while, this is one of my favorite phrases, and certainly it works really well for virtualization, and that is that everything is permissible, not everything is beneficial. What I mean by that is just because you can back up a VM from the host doesn't necessarily mean that you'll want to. Okay? It sounds like a cool idea. Let's talk about it. So when you put a single DPM agent on the host and you want to back up the entire VM, some of the things that are cool about that include you get to back up the whole machine. So for anyone who's ever wanted to do true BMR, for my money, the best BMR out there is to virtualize the machine and back it from a host-based perspective. Much easier than any kind of other image level backup that's out there today for physical boxes. So that's the cool part. You get to back up and recover the whole machine. Downside is there's no data selectability or granularity. You're backing up the whole VM. So that does mean, if you're backing up 50 VMs from the outside, you're backing up 50 copies of Windows. Right? So there's going to be some storage implications of that. You do get bare metal recovery as a concept. From a purchasing perspective, you only have to buy one agent. Right? You don't have to buy the DPM agent for the host, and you don't have any agents on the inside of the guest, so that can be cheaper, maybe even a little easier to manage. One of the other nice benefits of the scenario is that you get to back up non-Windows-based machines. Right? So DPM 2010, unapologetically, is focused on best for Windows. You can flip that around and say, not designed for Linux. Right? So if you've got 98 servers in your environment that are Windows and 2 of them are Linux, good way to get around this is to back up those 98 boxes either way you want, host or guest, and for those last 2 boxes, run them in VMs, and then we can happily back those up as well. And then I already mentioned the one single agent. Now, let's talk about if you put the agent in a guest, Now it's going to behave just like any other Windows-based backup does with DPM. So you can back up individual SQL databases or Exchange storage groups or SharePoint or files. The behavior is identical to the experience that you get when you're running on a physical production Windows server. Okay, so if you had to make this choice between, there's a couple things I want to make sure you're aware of. The most important one is that yes, you can do them both. Okay, so yes, you can put an agent on the host in the same way you can put agents inside the guests and run them at the same time, and no, they do not step on each other. Okay, more importantly, if you really want to save some money, this is where you all go, huh? Okay, if you really want to save some money, let me suggest to you that any time that you're thinking about putting DPM agents in your guests in a virtualized environment, this is a great reason to buy the System Center suites. Who in here already consumes System Center through the suites, SMSC, SMSD, or Essentials Plus? Okay, it's about maybe 20%. All right, so the System Center suite is just a soft bundle. So basically, you have the enterprise, you have the DPML, the Data Protection Agent, and in the suite, you also get the OML for Operations Manager, the CML for Configuration Manager, the VMML for Virtual Machine Manager, the SML for Service Manager. I think I'm missing an L. Anyway, there's 6, right? So there's 6 pieces, and basically the pricing model works out about buy 2 and a little bit, get the other 3.5 free. So ish. Okay. The reason I want you to think about those suites, let's assume for a second you had, and I'm hoping this session isn't being recorded, no need for Operations Manager, Configuration Manager, Service Manager, VMM, or Opalis. Okay. Let's say you didn't need any of those other products, which is truly insane, but we're going to go with it. And the only thing you truly needed was DPM. If you bought the suite and the only piece of it that you used was DPM, the fun part of the suite is you get use rights for all your guests at no additional charge. Okay, so if you're going to put the DPM agents in all those guests, and in fact, let me tell you the extreme example here, even if your hosts are VMware ESX, right, where you can't install the agent on the host because it's not Windows, you still get the use rights for the guests, so you still get a way to much more economically deploy the DPM agents in all the guests at no additional charge. So when you're thinking about virtualization, you want to put the agents inside the guests, really want to be thinking about using the suites. And oh, by the way, I hear the other products in System Center are really cool too. You should probably look at those as well. All right. Kidding. Some of them are mine also. All right. So that's kind of the virtualization landscape. When we actually set up protection for that, really the thing that you want to take away from that experience is if you just want to protect individual databases for protection and recovery, you're going to do that from within the DPM UI, and you'll simply go into that SQL server and you'll pick the database and you'll say, I want to back it up or recover it. If you want to back up the entire VM, then you'll simply go down to Hyper-V host, open that up, and you can see that. So let's take a look at that for just a second. Okay, so I've got a DPM server here, and in this case, I actually am doing the whole solution in place, meaning that I have a standing Hyper-V host. DPM is actually running on the host, which allows me to back up all my VMs, which is also really cool because it means I get to reset my environment right before every tech ed. So in this case, I'm backing up 3 VMs, a domain controller, FS1, and a SQL server. So if I go to the recovery UI, I can see here that I can see all 3 of the VMs. Now notice here, this is a really long explanation. It says, backup using child partition snapshot, / and the name of the VM. Okay, that's what Hyper-V tells us. When you actually try to back up that VM, it'll actually preface the name of the virtual machine with either this long description or backup using save state. The idea here is that right from the Hyper-V writer and within the DPM UI, you can find out exactly what kind of behavior that particular VM is going to have. If it says backup using save state, whack, FS1, it means it's going to hibernate that machine, snap it, and bring it back up again as part of the backup behavior. Because it sees something inside that VM which is not VSS capable and therefore not able to be secured while it's live. In this case, all 3 of the machines that I'm backing up, they're all Windows-based, VSS-capable guests. And so my domain controller, my file server, my SQL server, I can back all of them up while they're hot. And so the preface says backup using child partition snapshot, which effectively means I'm backing it up while it's live. So if I go ahead and say I want to look at all those machines, and I'll go ahead and expand this out so we can see a little better. So there's FS1. If the only thing I want to do is recover FS1, I'm pretty much done. I can pick a date. I can pick a time from that pull-down list. I can say recover. And now I can recover that VM directly back to the Hyper-V host where it came from. I can recover it to any other Hyper-V host that's in my environment. I can drop those files and the metadata that make up that Hyper-V host out to a network folder. Or if I had a tape drive attached to my shuttle, I could go ahead and recover to its own tape. And that way actually make that VM portable. Kind of a cool scenario if you think about it, because that way if you actually want to move large VMs from one location to another, you can actually say, I want to back up that VM, I want to recover it, and move it someplace else. It's also really cool for moving VMs from a test environment over to a production environment. But what's really cool, and one of my favorite features in the product, is I can go ahead and double-click on that FS1, and notice here there's only one VHD file that makes it up. Okay, so now if I look at that VHD file and I double-click on it, it's going to take a few seconds because literally right now what's happening is that my DPM server is temporarily mounting that VHD. Okay, once it does that, now I can see inside that VHD, I can see the definition of the volume itself. There's my machine, and hopefully you guys are seeing this in the back. If I scroll down, this is the C drive of that file system. There's the user subdirectory, admin, my documents, presentations, and here's the session we're talking about right now. Individual line item recovery from a VM-based backup, and I can put it any base on my network I want to. Okay? Y'all feel free to high five among yourselves on that one. All right, so that's virtualization. Great question. The question was, does it work on Exchange as well? No. It's item level recovery. So what you want is, so technically you could go and grab the EDB, and then if you go and copy that to an Exchange server, you could ask your Exchange admin to mount that. If you grab the MDF and the LDF, you could drop those over on a SQL server and have a SQL guy actually, or DBA actually mount those. But the idea here is this is based on file level recovery. If you want to do something which is application aware, you really want to recover that application data in the context of the app. And what that means is you're going to want to have made sure that you put the agent inside the guests for that. So that's the common reason why you'll put the agent in the guest versus the host. Okay, so that's virtualization, and I have no idea how I'm on time. When do we start? 1:45. So I'm about halfway through. Okay. So now we're going to switch gears a little bit. So for the last 2.5 sessions, when we've talked about data protection management, we've always talked about it from the context of production servers coming back to a DPM box. Traditional backup and recovery. If you were in the first session of the week when we were talking about introduction to DPM, one of the things I talked about was one of the design goals with DPM was to solve 3 kinds of problems. And one of the big ones was around supportability. Because many of you told us that you were running, and you guys check yourselves, make sure I'm saying this the right way. Many of you are running one kind of backup solution for nightly tape backup, and you've been running it for years. You've got a disk-to-disk backup solution for some of your workloads because you wanted faster backup and recovery of those workloads, or something that the tape backup didn't handle well on its own. And then in other cases, you're using some kind of disaster recovery or e-vaulting type technology to move your data between servers. And in many cases, you're running them from different vendors, which occasionally means the backup agents themselves step on each other. So one of the design goals that we had with DPM was to be able to provide disk-based, tape-based, and I'm going to call it cloud-based, in this case private, based protection in a single pane of glass. So one agent on the production server, one UI to manage the entire experience, but backing it up to multiple repositories, disk, tape, and remote. All right. So I've got my production environment here. I've got servers all across the geography, and then I'm going to, and let's say I'm doing something like synchronizing every 15 minutes. I'm protecting files every 2 hours. I've got 512 recovery points for all my applications, and with 15-minute deltas in between. You know, a traditional backup of production servers back to a primary DPM location. When you want to do recovery for disaster recovery, here's the fun part. All you're going to do is put a DPM agent on the primary DPM server and then point it at another DPM server. That's it. We handle everything else. Let's take a look at what that really looks like. So I've got, in this case, 4 production servers. I've got a file server, a SQL server, an Exchange box, and other file servers. So if you were licensing this, this would be 2 standard DPMLs, 2 enterprise DPMLs, and happily, there's no You don't buy the server anymore. I just realized it says DPM 2007, which is weird. Just as a side note, you don't buy the DPM server anymore. So if you own the agents, you already have the server. So all you're going to do is buy one more agent for the DPM server primary, and that's going to give you use rights for another DPM server someplace else. All right, there's a couple things about this scenario that are worth noting. One of them is the fact that we hold the data in a native state. Okay, so the data is held natively. It's on that SQL server. We really do have MDFs and LDFs. On the Exchange box, we will have EDBs. We talked about that earlier. What that means is that when we back it up that secondary hop, the data still stays within context. We still know it's SQL. We still know it's Exchange. We still know it's a file system structure. So if you're taking notes, here's one that I hope you take away with. This is my number one money saving tip from Microsoft. Do your tape backups from a secondary DPM server, because those tapes are in a different geography than where your production server is, and I haven't found any regulation yet where that doesn't constitute an offsite backup without paying for the guy in the truck to come lose your tapes for you. Okay? It's not an operational cost. You don't have to actually have the manpower to actually move the tapes and manage them and take them in and out of the drive. In fact, leave them in the drive. Leave them in a big changer at your secondary site, because you could actually restore from your off-site tapes back to your production server farm. Try that with the guy in the truck. All right? All right. So there's a couple other things that come out of that. One of the other ones is that the two DPM servers can actually they can protect each other, including, and this is a tongue twister, you can resume protection of your production servers from your secondary DPM box. If I break it down, I think it's a limerick, but basically what it means is if the primary DPM server fails, that secondary DPM server will actually continue protecting the production environment. And then when the primary DPM server is ready to be rebuilt, you can simply treat it like the secondary DPM, and then literally with a single mouse click, you can flip them, and that reverses their roles again. So now the on-premise is doing the primary protection, then it goes offsite afterwards like a buffer. There were actually several things that got changed in DPM 2010 around the scenario. One of them I just mentioned is that single click for failing over and failing back, the protection and recovery experience. Another one that we did was we changed the scheduling options in DPM. So now you can have a lot more flexibility as far as I mentioned before, you might protect the production environment every 15 minutes, 30 days on disk. And then on the secondary server, you might say protect every 2 hours, 90 days on disk, plus tape. Right? So you can have very different schedules. You're just adding another layer to the scenario as far as backing that up. Some of the other things we added in 2010 were things like chaining support. So it turns out, let's see, so we got two halves in the room. So if you guys are site A, and you're protecting to DPM A, and DPM A is protecting to DPM B, and then y'all over there, you're on site B, you're protecting to DPM B. If DPM B tries to go to DPM A, it turns out the space-time continuum actually breaks. It's icky bad. So in DPM 2007, you actually couldn't do that bidirectional kind of replication. In DPM 2010, you can also do chaining. So you can go A to B, B to C, C to A. It just becomes like linking logs, and you just kind of mesh them together however you like. And then, as I mentioned before, being able to have offsite tapes, as well as being able to directly store from the remote repository directly back to the production farm. Yep. So the question is there compression and or deduplication? We don't do any software-based deduplication, but we can use any deduplication device that presents itself as either block-level storage or VTL. We can use it behind the scenes. Yes, we do compression. Yes, we also do encryption over the wire, but when I say we at that point, it's actually Windows doing it, because it's actually an IPsec policy to create a tunnel between the IP addresses between one side and the other. You can do compression. I'll tell you that when you're anytime that you're doing compression or throttling to a lesser degree, you're buying bandwidth and paying for it with CPU. So just be aware of that when you're going from either the DPM servers across, because you're going to be adding some additional churn to go ahead and do that compression before it goes again. I'm not saying it's a bad thing. I'm just saying that's what you're doing, is you're buying network bandwidth with CPU. And these days, that's a pretty cheap commodity. All right, cheaper than bandwidth anyway. So we talked about disaster recovery, and we always talked about it making an assumption that you've got two sites, right? Not everybody does. So let's talk about some of the scenarios where if you don't have a secondary site, some options that you have. So this is the standard DPM design. One of the new features, some of you might have visited the Iron Mountain digital booth downstairs. So Iron Mountain has had a relationship with DPM for about 3 years now, since DPM 2007 Service Pack 1. And the idea is that instead of having a secondary site of your own, you have the option of using an Iron Mountain data center as your secondary facility. So what will happen is the experience is identical on the production server. We've designed DPM to do this. So inside of DPM's UI, there's an option called Configure Online Backup. And when you configure online backup, it'll take you to a page where you can subscribe for the service. It puts an Iron Mountain agent called Cloud Recovery on your DPM server. And so there's still nothing except Microsoft technology on the production servers, but that guy gets a Cloud Recovery agent, and he'll send the data off to your secondary location. And if you're really going to get frisky with your data, Iron Mountain will actually replicate it from one of their data centers to another one of their data centers, which I think actually gives you 5 live copies of your data, which I think is insanely cool, but some of you might want to be more prudent than that. All right, a little closer to home, there's a company called Jasco. They have an offering called eFort, and they have a very similar offering for this just for the Australia-New Zealand area. So you might want to check them out as well. And then lastly, there is a company called i365. They're a Seagate company, and they actually have done something interesting. Along with they do also have a cloud repository also. However, the entry point to their cloud is something rather unique. Instead of you taking your DPM software and putting on a copy of Windows and then building your own DPM box, which is everything we covered in the first session this week, you can buy an appliance straight from them. Basically, you open the cardboard box, and it's a really cool green face-plated piece of hardware. Everyone needs at least one of those in their environment just because it's really pretty. But you get it out, and literally like within 10 minutes, you are backing up data. Fun data point here, by the way. You're not only using the DPM software to back up your Windows-based data, you're also using their software to back up the non-Windows-based machines in your environment as well. So they have heterogeneous backup software as part of the appliance to partner up with DPM, and then all of it goes off-site to an i365 cloud. So you've got some options there. All right. Okay. Kind of on my last little area, and I think if I've budgeted this correctly, I actually have some time for questions, actually during the session, which is like unusual this week. So we're going to talk about how to mix the two together. So typically one of the biggest challenges that we often hear about when it comes to disaster recovery, and the title of this slide should kind of give it a little bit of a way, is in a lot of cases, if you have a physical production server farm, and you want to do disaster recovery, the old school of thought says, I'm going to need to go and stage some physical hardware at that secondary site and match it up. Right? And there's a whole lot of different replication companies. They'll be happy to sell you some software that will keep one set of hardware looking exactly like the other one and fail it over kumbaya if something goes wrong. Okay? Here's the problem. Do you really want to buy a second entire physical plant of your production servers and, oh, by the way, maintain power and cooling and space and operational costs to maintain that secondary server farm? Most of us in here would probably say no, right? You guys say no. Thank you. Thank you. All right. Yeah. So, but we know there's a better answer than having that secondary physical plant with power and cooling and space. You virtualize it. Right? So even if you're not even if your production farm is not yet virtualized, doesn't necessarily mean that your DR site can't be. And it turns out, with just a few tips and tricks, this is actually a pretty scalable thing to do. So we're going to start off with, and by the way, I decided to pick the oldest physical server icons I possibly could, which is why they look so cruddy on that left-hand side. I figured out the other day, I think one of them was actually a Mac 2, which I just think is funny. Anyway, so old physical boxes, which you obviously do not want to recreate as a secondary physical plant someplace else. So instead, we've been talking through all the sessions around DPM protecting the data, right? So we're going to replicate the data up to every 15 minutes based on the workload, blah, blah, blah. Been there, done that. Another part of System Center, Virtual Machine Manager, has a little function called P2V, Physical to Virtual Migration Utility. Normally, when you P2V, you're doing that as part of a migration, right? You're doing one last image of that physical machine. You're doing a translation of the network and the storage and everything else. And then now it comes up in a virtual machine. And typically what happens is you power down the physical server, you bring the virtual one up, and kumbaya, you are now virtualized. How cool is that? And oh, by the way, the rest of the registry and the machine identity all stay pristine, so it's a nice equivalent combination. So that's what happens when you want to migrate. Turns out you can do the same thing as a DR staging scenario. The only difference is that you don't actually power up the VM until you actually have a problem. Instead, on a regular basis, maybe it's bi-monthly, maybe it's ad hoc whenever you've done some change control, but whatever the scenario is, every few weeks you run this P2V utility. That's going to repackage that physical server into a virtual one and then pull that across to your secondary site, and now you've got this virtual copy of your old physical server ready to go. There is a third part you need, and I'll explain why in just a minute because it's not going to match right now. You need system state from the physical servers. Or you may need system state, and I'll tell you why in a few minutes. System state and bare metal recovery are both capable of being done from DPM as well. You put them on a separate schedule. Because normally what you want to do is you want to have the data schedule be up every 15 minutes or as quickly as you can. Normally you'll do system state, say, every couple days or weekly as a normal rule of thumb. So you'll set up on a separate schedule for that. But now I've got all three pieces of what I need for my disaster recovery site. And I'm doing that just with System Center Data Protection Manager along with System Center Virtual Machine Manager. Now I'm going to go ahead and add System Center Operations Manager to monitor the health of my production environment. Right? Now if you, from here, and by the way, I should mention, if you really want to know all the steps that we're talking about here, and I've got some batch files as well, this is actually a chapter from the book I'm giving away later, but if you go out to dataprotectionbible.com, I think that chapter is actually online, or you can at least look at it while it's on the screen. So a lot of the batch files I'll tell you about here, you can actually capture as well. So here's how the rest of the process works. You use Operations Manager to check the health of the environment. When you decide that something has gone wrong, pow. Okay, everyone say that with me. Pow. Pow. Okay, everything's gone wrong. The production server side is blown up. All right, again, oldest looking icons I could possibly find. Now we need to actually declare a disaster. So it turns out that when you want to do this, one thing I would tell you to do is never, ever, ever let any technology decide when it's time to fail over. Okay? You can let those technologies decide, or at least inform you that it thinks everything is dead and should be failed over, but you never want some proverbial monkey to push the button for you. You want to make that as an educated decision and say, yes, I agree, there's smoke coming out of the back of the box, or there's 4 feet of water in my server room, I think I should go ahead and fail over now. Okay, so you should make that as an intentional and educated choice. But once you've made that intentional educated choice, you want to automate everything you can after that decision. Okay, because the last thing you want to do is say, I've decided to declare a disaster. Get out the big book. And then you unlock the book and you take it over to the server operator and he starts going through the pages and step by step and turning everything back on. That is not what you want during a disaster. 1, the book might be underwater. 2, that server operator may not be there. Okay, so you really want to automate as much of the process as possible after you've declared a disaster point. With that in mind, turns out everything in System Center is manageable by PowerShell. Okay, so you can actually go ahead and create the scripts in advance to go ahead and take care of everything from this point forward. Now, to start off with, we need to go ahead and bring the VMs online, right? And you can do that by PowerShelling through Virtual Machine Manager. That actually is not the PowerShell syntax. Start up the instances. That's not how it actually works. But it's actually really close. The command in PowerShell is start-vm, right? And then the name of the VM and which host you want to put it on. And if you have multiple Hyper-V hosts, VMM will take advantage of intelligent placement. It'll figure out which host has the best available resources to bring it online with. But it really is pretty much that simple. Start VM and the name of it that goes afterwards. One line. Okay? Then after that, you're going to need to then bring the data online. So now I've got VMs, right? So the registry's there, the machines match, pretty much identical. The only difference is they don't have any data. Right? So now we're going to have to go get the data out of them as well. And of course, DPM, just like VMM, is also PowerShell controllable. And so now you've got a couple options. You could tell DM, hey, just restore the data back. Right? It's already got the agents on it. Just start restoring data. And you can do that. You could also, if you have a SAN underneath that Hyper-V host, you could go ahead and actually just snap the LUNs off of the DPM storage pool and then remount them underneath those VMs. And that actually gets you some interesting scenarios as well. But one way or the other, you now have live copies of your server from a few days ago. It's got data up through last 15-minute sync, or whatever the last data point is. All you have to do is reconnect the users. Okay? Now, by the way, one thing that makes this even more interesting, anyone in here have a user base which is primarily remote to where the data center is? Okay, about 30, maybe 40% of the room. So if you have that, if you have something where your user base is already going through some level of abstraction before they get to the production server farm, this gets really elegant. Because now all you have to do is redirect the DNS pointers or IAG or however you want to handle it, but somehow along the way you just change the routing when they get to this intermediate point, and instead of telling them to go to the left, you tell them to go to the right. The rest of the experience is identical from their perspective because they're already going through a couple different layers before they get there. And then one thing that more and more we're starting to see interest in from a Microsoft perspective is the idea of channel partners that provide consulting services, particularly to small and medium businesses, looking at doing this as a service offering to their customers, to your customers, right? Raise your hand if you're a channel partner. Okay, what, 25, maybe 30% of the room? All right, so if you're a channel partner, so here's the idea. If your customers are primarily small business and anything blows up in their environment that they're going to need any kind of technology help on, you're their first call anyway. So wouldn't it be cool if you already had their data? Right? And especially if it's already virtualized, because then you can just say, hey, I'll go ahead and take my copy of your VMs, I'll put them on a Hyper-V host, and I'll be there in the morning. Right? So there's some interesting scenarios here from a channel partner provider. This model also works equally well if you are a large enterprise with remote branch offices. Being able to do this kind of math where if a production server at a branch fails, you can say, look, instead of me sending out a guy to go and fix that branch, I'm going to go ahead and spin up the virtualized version of that branch at the data center. Yeah, it's going to be a little bit slower, but I'm going to get you up and running. And then we'll worry about whether how to put that server back in your production site again. So you've got some choices there. All right. I think that's the end of it is, and I've got about 6 minutes left. So I want to take a few questions. Before we do, though, a couple things of housekeeping. If you haven't heard this already, we'd really like to hear your evals. So please make sure you take the time to do that. Hopefully this is the stuff that you wanted to hear about from this session. If you really like the session, please make sure you do an eval and tell them that. If you don't like the session, don't worry about the evals. They're not that important. Kidding. Really kidding. But let us know what kind of stuff you need. I will take questions. Before we do, I do want to, I have one last copy of the book that I'd love to give away to somebody here. You can buy it from a New Zealand bookseller, but I think it's like $80, and I figure free is better. So let's do this. Who in here is already running DPM 2007 or DPM 2010 in production today? Raise your hands. Great, about 30% of the room. If you are protecting more than 50 data sources, databases, storage groups, virtual machines, etc., raise your hands. All right, keep them up for 75, 100. Okay, it's a race. 150 data sources. 200. All right. Oh wow, 3 in the back of the room. All right, so let's do this. How many data sources and what are you protecting? How many? 300 or 400 data sources, and what kind of workloads? File and SQL. Very cool. Very cool. Over here? 300 also? Virtual machines and Exchange. Okay. And file. Now, I can't imagine anyone not using file because that's just too easy just to point out. And then in the back? How many? Oh, same company. Well, that's not going to help me out at all. Thanks very much. All right. You know what? I've got one copy here, and I'll give it to the tall gentleman who's been raising his hand the whole time. And one of you can come up afterwards. I've got one more copy back behind the stage, and I'll get that to you as well. So thank you both for sharing your environments. All right. I got 4 minutes left. Let's take any questions on anything related to DPM to kind of finish this off until he kicks me off the stage. Yes? Oh, I love that question. Yeah. So the question was, what's the rollback? That's why you need system state. All right, so there's 2 recovery scenarios. One of them is that your customer goes ahead or you go ahead and start leveraging everything from a virtualized infrastructure, and you say, you know what? Maybe I wasn't planning on being virtualized until next year, but sure enough, this stuff is working pretty well. I'll just go ahead and stay virtual, in which case all you do is just cart some new Hyper-V hosts in. And by the way, what you may find is, let's say you protected 100 VMs in this configuration. Your Hyper-V host may only be able to support 20 of them right now. So you bring up the most important 20 now. You have arrangements with Dell or HP to drop in a few more boxes to bring those other 80 up online. Now you've got these 5 boxes. You're up and running. Just pull those 5 boxes in your data center and you're done. Okay, that's scenario 1. The other scenario, though, is I'd like to go ahead and go back to a physical plant. Right? DPM and Microsoft have a, not DPM, System Center and Microsoft have a P2V function. We do not have a V2P function. Okay, so we don't take you from physical and put you back into physical, which is why you want to capture system state. Because now you can go ahead and take a clean physical piece of hardware, you can install Windows on top of that, and then because you were capturing system state from like 3 or 4 slides ago, you can play the system state back. That gets you to the registry and everything else on real hardware, and you're good to go. Now, I joked earlier about how the hardware in the production plant may be older. So let's say that you're using HP DL380 G5s. They're a little older, a couple years out. Turns out, if you go and you buy a G7, it's 2 steps off, but oh, by the way, the HAL is the same. Smart SCSI is still recognized. Netflix is still recognized. You know, all the major pieces are still there. It'll adapt for that. I probably would not have done a system state of an HP machine and try to replay it onto a brand spanking new Dell, or vice versa. But that's why I use system state, is so that if you want the option of recovering the physical plant, you can do it from there as well. I would say that normally that you're going to go ahead and still take those Hyper-V hosts and move them to the production site so that you can repopulate the data locally. The users are touching it, move that locally, and then bring them online again. But that's kind of a hat trick at that point. All right, yes? Say the first part of that again. Oh, Palace, yes. It would, and in fact, the Opalis integration pack for DPM is planned for later this calendar year. So a lot of the common tasks, a lot of the verbs that you see me do around protection and restore this kind of data object, et cetera, those are all actionable tasks in the Opalis integration pack. So you'll actually be able to manage all of that through there, which makes all these canned scripts go away. Until they go away, though, go to the book's website and you can get them from there. Yes? Does DPM support backing up VMs from other hypervisors other than Microsoft? I wish they did. The bottom line is that the secret sauce for every workload that DPM does is VSS. And so, you know, things that use a vStorage API or some other function like that, if it's not VSS, we can't plug into it. If they would like to open up those gates to allow for a VSS provider or writer, then I would be happy to back them up. And then help you migrate them over to Hyper-V. But anyway, that's a different conversation. Yeah. All right, let's take 2 more questions, and then I need to shut down and get out of the next speaker's way. Yes?
You talked about the licensing model where you use license to guests and use license the suites.
Yep.
Is there any way that I can make that work for customers of mine that have their hosting in virtual data center facilities?
Yeah, so if you're doing hosting already, what you want to do is talk to your Microsoft rep on something called SPLA licensing, service provider licensing, and basically the model for SPLA is that it allows for the licenses to not be owned by the end user, but to actually be paid over time, and you as the service provider ends up actually carrying the note for those. All right, last question. I got to get out of the next speaker's way. Yes. So if I hear the question correctly on backing up Exchange, you don't need a local store. What you need is you're just using you're using VSS off the production server. The Exchange VSS writer handles all that plumbing for us, and the VSS provider at the software layer stores those intermediate changes long enough for us to go and grab them. Go check out the podcast I did, and it'll actually walk you through that workload piece, and that'll hopefully clear it up for you. Hey, thanks again, everyone. I hope to see you next year at TechEd. Thank you.